Good morning, students. In this particular video presentation, I will continue with the remaining part of your board tech paper 1. I have discussed already till question number 15. Let me continue with question number 16. Using properties of determinants, show that determinant x square plus 1 into xy, xz, yx, y square plus 1, yz, zx, zy, z square plus 1 is equal to 1 plus x square plus y square plus z square. Just see the question, 16th question. Just read the 16th question. Let me just see. Listen. Let me see how we go about it. Determinant 1 x square plus 1 xy xz yx y square plus 1 yz zx zy z square plus 1. This is my LHS. What I intend to do here is, let me take x, y, z as common from R1, R2, R3 respectively. This will become x plus 1 by x, y, z. This will become x, y plus 1 by y, z. This will become x, y, z plus 1 by z. Okay. You can write the reason over here. There is no space, therefore I am just explaining. Take x, y, z as common from R1, R2, R3. Now multiply this with C1, C2, C3. Therefore this will become x square plus 1, x square, y square plus 1, y square, z square, z square, z square plus 1. Write the reasons every time. Here I am taking x, y, z as common from R1, R2, R3, and I am multiplying x, y, z C1, C2, C3. Now let me just apply C1 going to C1 plus C2 plus C3. What do I get? 1 plus x square plus y square plus z square, y square, z square. 1 plus x square plus y square plus z square, y square plus 1 z square. 1 plus x square plus y square plus z square, y square, z square plus 1. Okay, let me take 1 plus x square plus y square plus z square as common from C1. 1 y square z square, 1 y square plus 1 z square, 1 y square z square plus 1. And it is always easier for anybody to follow if there is 1 on 1 in one of the columns. Always write R2 going to R2 minus R1, R3 going to R3 minus R1. What do I get? 1 y square z square, 0, 1, 0, 0, 0, 1. There is 1 plus x square plus y square plus z square. Expand using C1 now. 1 into 1 minus 0 minus 0 plus 0, which is reduced to 1 plus x square plus y square plus z square, which is my right hand side. Let me explain the whole lot. Take x, y, z as common from R1, R2, R3. X plus 1 by x, y, z. X, y plus 1 by y, z. Okay. Then here x, y, z plus 1 by z. Multiply x, y, z at C1, C2, C3 now. X square plus 1, x square, y square plus 1, y square, z square, z square, z square plus 1. Apply C1 going to C1 plus C2 plus C3. 1 plus x square plus y square plus z square, y square, z square. 1 plus x square plus y square plus z square, y square plus 1, z square. 1 plus x square plus y square plus z square, y square, z square plus 1. Take 1 plus x square plus y square plus z square as common from C1. 1 y square z square, 1 y square plus 1 z square, 1 y square z square plus 1. Apply R2 going to R2 minus R1, R3 going to R3 minus R1. Write this again. Okay, the bracket should be after this. Okay, this is after this equality sign. 1 y square z square, 0, 1, 0, 0, 0, 1. Therefore, expand using C1. I get it to be 1 plus x square plus y square plus z square. Write the reasons everywhere, whatever I already told you. Leave for writing the reasons. You will be given full marks. You will be given full marks. Okay, next problem. Find the shortest distance between the lines r vector equal to I plus 2j plus 3k plus lambda times 2i plus 3j plus 4k and r vector equal to 2i plus 4j plus 5k plus mu times 3i plus 4j plus 5k. Read question number 17. Read question number 17. Okay. Now actually this is the problem under skew lines. Two lines are supposed to be skew lines if they don't intersect or they are not, neither they are intersecting nor they are parallel. You can get a situation like this. Okay, you can get a situation. They are neither parallel nor intersecting in space, let us say, in space. Okay, now let me write the given lines. R vectors equal to I plus 2j plus 3k plus lambda times 2i plus 3j plus 4k. Okay, given lines are then R vector is equal to next one 2i plus 4j plus 5k plus mu times 3i plus 4j plus 5k. I plus 2j plus 3k, 2i plus 3j plus 4k, 2i plus 4j plus 5k, 3i plus 4j plus 5k. Okay, now line 1 passes through, that is A vector. This is my A vector, I plus 2j plus 3k, and is parallel to B vector. This is my parallel vector, 2i plus 3j plus 4k. Then line 2 passes through C vector is equal to 2i plus 4j plus 5k and is parallel to B vector is equal to 3i plus 4j plus 5k. This is the vector to which it passes through. This is the vector which is parallel. This is A, this is B. A is I plus 2j plus 3k. B is 2i plus 3j plus 4k. C is 2i plus 4j plus 5k. D is 3i plus 4j plus 5k. Now I need to find C minus A. What is C minus A? C minus A is I plus 2j plus 2k. I plus 2j plus 2k. It's correct. Now I need to find B cross D. Determinant I, j, k. What are the components of B? 2, 3, 4. What are the components of D? 3, 4, 5. Let me just simplify this. I into 15 minus 16 minus j into 10 minus 12 plus k into 8 minus 9, which is minus I plus 2j minus k. Let me just check. 2, 3, 4, then 3, 4, 5. 15 minus 16 minus j into 10 minus 12, k 8 minus 9, minus I plus 2j minus k. Now shortest distance between skew lines 1 and 2 is equal to modulus C minus A dot B cross D divided by mod B cross D. That is the application. Okay, now C minus A dot this gives you minus 1 plus 4 minus 2. Minus 1 plus 4 minus 2 divided by root of 1 plus 4 plus 1. That much units. What do I get? 1 by root 6 units. Okay, let me just check. Passes through this much parallel to this much. Passes through this and parallel to this. Find C minus A. C minus A is I plus 2j plus 2k. Okay, B cross D. 8jk 2, 3, 4, 3, 4, 5. 15 minus 16 minus j into 10 minus 12 plus k into 8 minus 9 minus I plus 2j minus k. C minus a dot b cross d minus 1 plus 4 minus 2. Numerator is 1. And modulus this 1 plus 4 plus 1. 1 by root 6 units is the final answer. That is the shortest distance between the given two lines. That is the shortest distance between the given two straight lines. Okay, then next one. Verify Rolle's theorem for y is equal to f of x equal to x square minus 10x plus 21 in the interval 3, 7. Just read question number 18. Read question number 18. Okay, now you are supposed to just recall that rule for Rolle's theorem. A function y is equal to f of x should be continuous in the closed interval a comma b. It should be differentiable in the open interval a comma b. Then at the end value is f of a equal to f of b, both should be equal to 0. Then there should exist at least one c in the open interval a comma b, so that f dash of c is equal to 0. That's the condition. Okay. Now y is equal to f of x equal to x square minus 10x plus 21 being a polynomial function. Being a polynomial function is continuous in the interval 3, 7, closed interval. Okay, now dy by dx equal to f dash of x is 2x minus 10 is finite in the open interval 3, 7. When the derivative is finite, function is differentiable. That's the meaning of differentiability. Therefore, y is equal to f of x equal to x square minus 10x plus 21 is differentiable in the open interval 3, 7. Now f of 3 is equal to 9 minus 30 plus 21 is equal to 0. F of 7 49 minus 70 plus 21, this is also 0. Okay, f of 3 is equal to f of 7 is equal to 0. Therefore, required 3 conditions of Rolle's theorem are satisfied. Okay, therefore, there should exist at least one C element of 3, 7 such that f dash of C is equal to 0. Now, f dash of C is equal to 0 implies, what is f dash of C is equal to 0? What do I end up with? 2C minus 7, 2C minus 10, sorry. 2C minus 10 is equal to 0. 2C is equal to 10. C is equal to 5, which is element of open interval 3, 7. Therefore, Rolle's theorem is, or thus Rolle's theorem is verified. Let me repeat the whole process. This being a polynomial function is continuous. Every polynomial function is continuous. Therefore, we are allowed to write like this. Derivative is a finite quantity in the open interval. Therefore, it is differentiable. F of 3 is 21 plus 9, 30 minus 30 is 0. 49 plus 21, 70 minus 70 is 0. The f of 3 is equal to f of 70 is 0. The required 3 conditions of Rolle's theorem are satisfied. There should exist at least one C in the open interval, so f dash of C is 0. F dash of C is 2C minus 10. C is 5. 5 is in the open interval. This is very important. I should check whether the value of C which I am going to get lies in the open interval or not. If I don't do so, my conclusion is wrong. That is the real meaning of verification. Am I able to get the value of C satisfying the given condition lying in the open interval, satisfying the condition f dash of C is equal to 0? That's the real meaning of verification. Remember carefully. That's the real meaning of verification. Okay. If y is equal to e raised to tan inverse x, show that y2 means d square divided by x square. y2 plus 2x minus 1 into y1. y1 is divided by x is equal to 0. See question number 19. Read question number 19. Let me just do, it's not difficult. Y is equal to e power tan inverse x. Therefore, y1 becomes e power tan inverse x by 1 plus x square. It's application of chain rule. For e power anything, it's the same thing. For tan inverse x is 1 by 1 plus x square. Just cross multiply. 1 plus x square into y1 is equal to y. E power tan inverse x is nothing but y. Now differentiating throughout with respect to x, we get, what do I get? I need to apply product rule over here. Let me try to apply product rule. 1 plus x square into y2 plus y1 into 2x is equal to y1, which implies 1 plus x square into y2 plus 2x minus 1 into y1 is equal to 0. That's what I am supposed to prove. Let me repeat. Y is equal to e power tan inverse x. y1 and dy by dx. So e power tan inverse is 1 plus x square. Cross multiply and do, your job will be easier. 1 plus x square into y1 is equal to y, because this is nothing but y again. Differentiating with respect to x again. 1 plus x square into y2 plus y1 into 2x is equal to y1. 1 plus x square into y2 plus 2x minus 1 into y1 is equal to 0. That's the one to be proved. That's what I am supposed to prove. I think it's clear. Now, next sum is, if y is equal to 3 cos log x plus 4 sin log x, show that x square into y2 plus xy1 plus y is equal to 0. Read question number 19, the second part. Just let me just see. Okay, question number 19. Y is equal to 3 cos log x plus 4 sin log x. Okay, my y1 will be minus 3 sin log x divided by x, application of chain rule, plus 4 cos log x divided by x. Okay, let me cross multiply. X y1 is equal to minus 3 sin log x plus 4 cos log x. Okay, now differentiating with respect to x, we get, what do I get? X into y2 plus y1 into y1 is equal to minus 3 cos log x by x minus 4 sin log x by x. Cross multiply x. What do I get? X square y2 plus x y1, okay, is equal to minus y. Take minus as common, it's equal to y. Therefore, I end up with x square y2 plus x y1 plus y is equal to 0. That's what I am supposed to prove. Let me repeat. y1 is minus 3 sin, for cos it is minus sin log x, for log x it is 1 by x, for sin it is cos log x by x. Cross multiply x. X y1 is minus 3 sin log x plus 4 cos log x. Differentiate again with respect to x. X into y2 plus y1 into 1 is equal to minus 3 cos log x by x minus 4 sin log x by x. Cross multiply x. X square y2 plus x y1 is equal to, taking minus as common, it is minus y. X square y2 plus x y1 plus y is equal to 0. That's the one to be proved anyway. Okay, I think it's not difficult for anybody to follow. Next one. Of all the rectangles inscribed in a circle, show that the square has the maximum area. See question number 20 over here. Read question number 20. Just listen. It's a problem on maximum minimum. Okay, just listen. You are given a circle. Okay, let me think about ABCD. Okay, this is the rectangle being inscribed. Let us imagine. Okay, now let circle be of radius or units. Okay, ABCD be the rectangle being inscribed with AB is equal to x units, BC is equal to y units. I assume like this. Okay, just listen carefully. What I will do here is, now in any rectangle, each angle is 90 degrees. Now angle ABC is equal to 90 degrees, which implies AC or CA is a semicircle. You might have seen in 10th standard, angle in a semicircle is 90 degrees, and the converse of which, if an arc subtends an angle of 90 degrees in the alternate segment, then arc will be a semicircle. Okay, using which this becomes a semicircle. Therefore, AC is a diameter. AC is a diameter. Therefore, this length is nothing but 2r. Therefore, in triangle ABC, I get x square plus y square is equal to 4r square. Now, area of rectangle ABCD is equal to A is equal to xy, which is x into root of 4r square minus x square. But there is a root over here. To avoid that, I am allowed to use this b is equal to a square is maximum if and only if a is maximum. You are allowed to use this. Therefore, b is equal to x square into 4r square minus x square. b is 4r square x square minus x power 4. db by dx is equal to 8r square x minus 4x cube. d square b by dx square is 8r square minus 12x square. db by dx is equal to 0 implies 8r square x minus 4x cube is equal to 0. Take 4x as common. 2r square minus x square is equal to 0. X equal to 0 or x equal to root 2r. This is not possible. When x is 0, such a rectangle won't exist. When x is equal to root 2r, d square b by dx square happens to be 8r square minus 12 into 2r square. Am I right? Which gives you, this is negative. Therefore, let me just continue here. When x is equal to root 2r, db by dx is equal to 0 and d square b by dx square negative implies b, and therefore a is maximum. Maximum when x is equal to root 2r. When x is equal to root 2r, y is equal to root of 4r square minus 2r square, which is also root 2r is equal to x. X equal to y implies ABCD is a square. That's the way you should do. Let me repeat. I assume the radius is equal to be r units. I assume ABCD is the rectangle inscribed in the circle with AB equal to x, which is BC is equal to y units. Now this angle is 90 degrees implies this arc AC or CA. Either way you can write. Of course CA you may write. You can even write CA or CA here. Doesn't matter. Okay. Or CA is a semicircle. Or CA you can write. Okay. Or CA either way is correct. For AC is a diameter. I use x square plus y square is 4r square. Therefore x into root of 4r square minus x square is the area. To avoid the square root, I am taking squares and proceed. B equal to x square into 4r square minus x square, 4r square x square minus x power 4. Take dB by dx 8r square x minus 4x cube. D square b by d square, here 8r square minus 12x square. db by dx is 0 implies x is 0 and x is equal to r. X is equal to 0 is not possible. When x equal to root 2r, d square b by dx square is 8r square minus 12 into 2r square, which is negative. Now for first derivative is 0, second derivative negative implies b is maximum, therefore a is maximum when x is root 2r. When x is root 2r, I am able to prove y is equal to root 2r is equal to x. If x and y are implied, x and y are equal implies ABCD is a square. ABCD is square. I think I have done till the 20th problem. Okay, I think I'll be able to continue with the remaining in the next video. Thank you.